Hello guys, it's the tutor here. And in this video, I'm going to explain to you integration by substitution and work through some examples with you. So what is integration by substitution? Well, you can use this method whenever you have a function of a function that is multiplied by its derivative. So that's basically, I'm basically restating this line right here, right? So what you can do is you can plug in a substitution of u in place of the inside function. So let me show you an example. So let's say you want to take the integral of x cubed plus 3 times x squared, right? Well, that's equal to your f prime of x per se, right? So you can say, you see how there is like you have this here, right? But then you have the derivative of that over here, right? But it's d over dx of it, right? You have it there. So what you can do is you can set this term as u, right? And then you can take the derivative of that. So you will get du, then 3x squared dx. And then what you see is you have this term right here in your integral, right? In your integral right here, you have it there, right? So you can substitute that in, and you also have a term for u. So you can plug in u for the function. And now you have an easy integral which you can integrate, right? It'd be the integral of u over 3, which is going to be u squared over 6 plus your constant, right? And now if you want to prove to yourself that this is right, well, we can work backwards here, right? Here, right? All you have to do is, so if you want to take the derivative of this, it's going to be x cubed plus 3 using the chain rule, multiplied by 2, right? And then the derivative of the inside, it's going to be 3x squared, right? And then that's the 6 and the 3 will cancel out, and it will just end up with x squared times x cubed plus 3, which is what you started with. So let's go through an example. So starting on the left side, I'm going to use the red pen now. You have the integral of x over root 1 minus 4x squared. So right away you see in the top, right, you have x, which is 1 power less than this entire polynomial, right? So you could use a U-substitution of this being the parent function. I'm going to call it the parent function. And then you have the derivative of it right here, of the parent function, correct? So setting u to be 1 minus 4x squared, take the derivative of it, right? You isolate for the terms you have in there, and the term you have in here is this, right? You have this over here, so you're good. You have your integration operator. So now let's rewrite the integral, right? So we'll replace this green term, right? So you're going to get -1 over u, and the -1 comes from this -8. So you just move the negative to make it easier. That's it. Over root u, because we replaced 1 minus 4x squared by u, and then we multiply it by we substitute the x dx, which what you get there. And now to make it easier, instead of having a root here, we make it u to the -0.5. We integrate that using the reverse power rule, so -0.5 plus 1, you will get u to the 0.5, the negative is still there, divided by 0.5 times 4, so 4 plus c. And then we're given it in terms of, we're given the original question is given in terms of x, right? So we're going to want the answer in terms of x. So we're going to substitute back in u. So it's going to be u to the 0.5, so root of 1 minus 4x squared, it's negative, put the negative in the front, over 4 plus c. Next example. So for this one, right, you could just multiply in if you had time, but why? You have this here, and you have the derivative of it right on the outside. So why do that? So just set u equal to 3 minus 10x cubed, right? Because we have the derivative of it on the outside. We have x squared on the outside, which will be the derivative of the inside. But let's say, for example, you had a t over here. Then you wouldn't be able to use U-substitution. Because why? The derivative of the inside would not be on the outside. If you wanted that, you would have to have x squared minus 1, for example, or minus 3 on the outside, right? Minus 3, not minus 1, minus 3. Or plus 3, sorry. Right? So you don't. So, but here, it's, the t is not there, luckily. So we can use U-substitution. So setting u equal to 3 minus 10x cubed, you get du, right? And what do we need? We need x squared. We need x squared, and we need the dx, right? So this is what the term that we need. Isolate for it here, and then plug it in, right? You get u to the 4, substituting this in for u. The integral of u to the 4 du over negative 30. Constant carries over. U to the 4 just becomes u to the 5 divided by 5 plus c. And then we substitute back in u, right? Which will give you 3 minus 10x cubed all to the power 5 over negative 30 times 5 plus c. Now, in this one, so you have 2t cubed plus 1 over bracket t to the 4 plus 2t close bracket cubed dt, right? You need to integrate that. So the first thing you should be thinking, it should automatically come to your head that this is going to be my substitution. Why? Because it is a function of a function, right? Because the function here, technically, is just x to the 3, right? But x is equal to t to the 4 plus 2t, right? That's basically what it is. And then you have the derivative of that function on the top. So you can use U-substitution, right? So we're gonna set this as our u, right? And then we're gonna take the derivative of that, and we see it's a factor of 2 higher. So we're gonna factor out a 2 here, right? And then we're only looking for 2t cubed plus 1 dt. So we're gonna isolate for that, right? Because this is the term we want to substitute in for the derivative, right? After we've done that, we get 1 over u, which just gives you d over 2, right? So 1 over u cubed times du over 2. The integral of that is very easy, and we just use the reverse power rule. U to the negative 3 over 2 du is just equal to u to the negative 2 over negative 4 plus c. And then we plug back in our u, and we're given the answer right here. T to the 4 plus 2t to the power of negative 2 over negative 4 plus c. And it makes sense. Think about it. This, the original over here, right, is to the power of negative 3. When you integrate, your power goes up by 1. Remember from the reverse power rule? And look at this answer. It went up by 1. Right? Now let's do this one. Okay. So over here, right, we have 2t cubed plus 1 over t to the 4 plus 2t. It's the same one as that one, except on the bottom, it's not a polynomial or a rational, right? So before we start this one, this identity is very important to note. Very important to note this identity, right? So 1 over x, you cannot just use the reverse power rule. It's actually an identity. It's equal to ln x dx. It's equal to ln x, not dx. It's equal to ln x, right? Because think about it. The derivative of ln x is equal to 1 over x, right? And the integration and derivative are opposite operations, right? So knowing that and knowing our previous example, we're going to pick u to be t to the 4 plus 2t again, right? It's this one, right? And this is what we're looking for. In the derivative of the u function, we need this. Do we have that? Yes, we do. So here, du over 2 is equal to 2t cubed plus 1 times dt, right? substitute that in. It's going to be du over 2 times u, which is equal to just what? No, coming from this identity, just using it here, is going to be ln u over 2 plus c, right? And then, like we did for all the other examples, we're going to plug in u, we're gonna back substitute it, so it's going to be the ln of t to the 4 plus 2t over 2 plus c. Now, we know, again, that the derivative of ln x is just 1 over x, right? So let's go back to prove to ourselves, right? So the derivative of this would just be what? It would just be 1 over t to the 4 plus 2t, and then on the top, right, we're going to need the derivative. So 3t cubed plus 2, right, over 2. Right, my bad, 4, not 3. 4, right? 2 will cancel out. This will just become 1. This will become 2. And we're where we started, because the c is just going to be 0, right? Plus 0. Now, one last example, right? So right away here, you should see that this should be a parent function. It's the polynomial per se, because you can just say that u is equal to that function. So u is going to be to the second power. Sorry, not polynomial, rational. Excuse me. So u will be 5y squared plus 4 du is going to be 10y plus 0 dy, right? So we need what? We have 3y and we have dy, right? So what can we do here, right? Well, du, let's just isolate for y. Du, well, here's a trick. If you see a number like that, just bring it outside, okay? Do it like this, right? Because then now all you need to do is look for y. Very easy, right? Y dy, right? Because 3 times the integral of x dx is equal to the integral of 3x dx. This is very important, okay? So now we're going to back substitute this, right? Or not back substitute, we're going to substitute into the integral. So it's going to be du over 10 times u squared, right? Now what is this? This is just equal to the integral u to the negative 2 over 10 du, which is just equal to u to the negative 1 over 10 negative 10 plus c. See? Now plug in u again, right? U was what? 5y squared plus 4 to the negative 1 over negative 10 plus c. Right? Okay. So let's write a general procedure for these, right? So first, identify the parent function, right? So meaning identify which one is going to be the g of x, right? 2, take the derivative of g of x, okay? 3, substitute g prime of x and g of x along with the integration operator. So that integration operator being like dx, dy, stuff like that, right? So change the integration, change the variable of integration. Let me write that actually, that's better. Yeah. I'll write that on the next one. So actually right here. And change variable of integration. right? So that's just being the du or whatever. Du, dx, dy, right? 4, integrate 5, substitute, no, change variables back. So if the question was given to you in the variable of x, you're going to put your answer in a variable of x. That should be it. And I hope that helped. Have a great day, guys.